Okay guys, what is friction? What is the name of friction? We have to firstly understand the definition of friction. The definition states that the force that acts opposite to the motion of an object contact to each other. You have to remember one thing, that this should be contact to each other, like this cupboard, contact to the floor, anything. When you contact your palms together, try to just slide each other. That is a good example for friction. So according to the type of surface, you can see the friction changes. If you try hands together, likes of your palms together, if you are a sports person or someone who has to done some work, so your arms are really rough, then you can see certain higher kind of friction. If your hands are really smoother, arms or palms are going to be really smoother for girls and many people who doesn't do much work, then their palms are smoother, then the friction is extremely lower. And when you try to rub your face, you can still see the friction is lower. Like that, you can understand according to the surface type of the surface, the friction change. So however, there is a thing called friction. Friction is always affecting against the type of motion what you are trying to cause. Sometimes you might not be able to make a motion at all if you are trying to pull a very heavy old table. It's really hard. Why? Because the frictional force can overcome the force that you apply from externally. Even though you are dragging something against a certain rough surface or any surface, you can still feel you are not getting the 100% effect because the friction cut loose some of the amount. So let's find how the friction is just going to work. When two surfaces are contact to each other, when you are trying to drag something against the other surface and with a certain relative motion, you know what is relative motion, so there is a frictional force effect whether the thing is just moving or just trying to move somehow. So if we just consider what is the reason behind, now see this one, the image, according to this image, now you can see the stuff is just cracked. So you can see microscopic level crack, even though the surface looks really finer and smoother. Now check your on like a whiteboard something, but it looks really extremely smoother, but actually they are not that much smoother in microscopic level. If I enlarge the magnification, you can see very big trenches and drainage system like things. Okay, if you increase furthermore, you can see it like those two are just tagged to each other, like of fitting, like building blocks you fit to each other. So whenever you put a certain force in some direction, there is an opposite force generates according to the Newton's third law. This is also something belongs to Newton's law. So friction is somewhat like Newton's third law. It's not exactly, sometimes it exceeds, not the exact amount it can give. You will see what I'm talking about. Now let's move to the mathematical application of friction. This is the overall theoretical application. So the friction changes with the type of surface that I have mentioned. Apart from that, the reaction force also going to matter as well. When you have higher reaction force, that means when you pile up more force, weight on this one, the friction is going to be really high. If you are trying to drag the certain table, then you keep some books and some other stuff on the table, then it's going to be really hard. So you have to understand one thing, the friction varies with the reaction force. The friction force is directly proportional to the reaction force, so I have to put certain proportionality constant. The proportionality constant is mu. The frictional force F is equals to mu r. Frictional force is equal to mu r, and the r is nothing other than for mg in this particular case, because we just draw a free body diagram along the vertical axis. So now you are substituting mg instead of r. Now the result becomes mu mg. Okay, there's a certain very simple example in this example. It's a 5 kg mass. You are just going to drag it. So alongside using some force and a friction, and the mass is just mg. Weight, so the frictional coefficient is mu. That we are just going to find out the maximum possible friction. Okay, F, the maximum friction is going to be mu mg. Let's find mu is 0.5, mass is just 5 kg, and the gravitational constant, I'm just taking rounded up to 10. So the result is going to be 25 Newton. Really simple. Now let's go for it. Let's analyze the result. According to this analysis, say this frictional force versus the external force, applied force. So in the first part, you can see the certain linear relationship. It has a maximum value and just comes down as well. What is this maximum value? Maximum value is the limiting friction. Limiting friction means the maximum amount of friction that the surface bear itself up. So no more force can be applied than the limiting friction. So next up is when the body is just going to move now. Now the body is just moving. Now the limiting friction just drops to some certain value. So that's the dynamic friction. That means the moving friction when the two surfaces are contact to each other, sliding past each other. Then the friction, dynamic friction, is little bit lower than the limiting friction. As an example only. Okay, don't consider this one as a real number. If the maximum FD, it's a maximum friction. So you are starting from 0. If the maximum friction is 100 Newton, the body is not going to move. But when you increase the force to some 101, then the begin to move. The maximum friction may drops to somewhere around, not exact value, somewhere around 80 Newton. What? Yes, the friction, maximum friction is now going to be really lower than the static friction. Before moving, it's supposed to be static. Now during motion, it's going to be dynamic. Okay, dynamic friction is bit lower than static friction. That's why when you start to slide, when you just try and walk, so you are continuously going to slide and you fell down, all because of the limiting friction. Dynamic friction is lower than the friction. You have to keep that in your mind as well. The next point. So a little bit tough question, not a simple one. It's going to be a really tough one if you don't understand the basics. So let's see. The dynamic friction and the force and the angle is just 30 degrees, and the coefficient of friction is mu 0.4, and you have to remember that the frictional coefficient with no unit, because Newton and Newton from both sides cancel out in this F equals to mu r. I just forgot to tell you about that. Okay, no unit. So now let's find the maximum possible force that you can apply to the object is just about to move, not moving until to just about to move. Okay, just about to move. Now I'm going to draw the free body diagram. Free body diagram, you can obtain it from this one, that R and mg. When you get it to R is not alone, this component from this one comes like what? F sine theta, and this component is along the horizontal is F cos theta. Now R and F sine theta, and according to horizontal line, there's a frictional force and the F cos theta component of the dragging force and the mg. Now you can say the FL is going to be F cos theta according to this horizontal component. Now considering the vertical, this is now considering the horizontal, and considering the vertical. What is the vertical component? According to this one, see, R and F sine theta altogether is equals to mg. R reaction force is mg here minus F sine theta. Now your equation is FL is equals to mu R. The R factor is going to be what? Mg minus F sine theta. Now the equations, now I'm going to equal these equations like FL, sorry, I accidentally written as LD. So FL mu mg minus F sine theta, of sine theta. Now I'm going to open the brackets and write F cos theta is equals mu mg minus mu F sine theta. Now finalize the equation is going to get F factors together. F cos theta plus mu F sine theta is equals to mu mg. Now the next part is F. Now I'm going to get just common factors out. Cos theta plus mu sine theta, mu mg. Now F is going to be mu mg over cos theta plus mu sine theta, and the mu is 0.4, and the mass is 10 kilogram, and the gravitational acceleration is 10, and the cos theta is plus, and cos 30 plus 0.4 times sin 30. Now the mathematical values for this one is root 3 over 2 plus 0.4 times half. Then finally 40 over 0.2 plus 0.2, and this is more likely at 0.86 somewhere around, because the square root 3 is something like 1.73. So plus 0.2 is like 40 over 1.06, and the maximum possible force that you can apply without the board to slice each other is 37.8 Newton. So in my next video, I'm going to apply some hard questions like exam level questions. So this is the first video of the series of friction. So stay tuned and just subscribe to my channel and get more updates. Okay, God bless you.